Hey guys, this is Algebra 2, Semester 2. This is Chapter 6, Section 1 from the Big Ideas Math text. And today what we're doing is going to explore some characteristics of the graph of an exponential function. Okay, so first things first here, we have a new function. It's f of x equals b to the x. This is where b is greater than 1. It is the parent function of the family of exponential growth with base b. The general shape is right here. So basically the asymptote is the x-axis. Remember, an asymptote is a line that we get really close to, but we do not cross. The graph is going to have the point 0, 1, and also the point 1, b. Remember, b is the base. Okay, it says the graph rises from left to right, passing through these points. Our domain is all real numbers. Our range is greater than 0. Y is greater than 0. Okay, now for growth, I also have one I want you to write on your cheat sheet. It's the initial amount A, 1 plus the rate of growth to the t. So it's almost the same, or at least it's pretty similar. And this is for our real life applications we're going to do in a few minutes. Okay, move on to decay. For decay, that b value is sandwiched between 0 and 1. So it is a proper fraction. And as you're going to see, the graph is falling from the left to the right. But the asymptote is still the x-axis, and the domain and the range remain the same. All right, tell whether the function is growth or decay. So you're looking at that b value, which is 2. 2 is greater than 1, so this is growth. 1/2 is a proper fraction. It is between 0 and 1, and so it is decay. Okay, let's try some. Tell whether it's growth or decay in graph. So you should be graphing these in your graphing calculator and taking a look at them. Okay, put me on pause. Here come the answers. We've got growth, decay, decay, and growth. Now keep in mind, 1/2 would be the same as saying 3/2 to the x, but that is an improper fraction. The value of the car, y, in thousands of dollars can be approximated by the model 25 times 0.85 to the t, where t is the number of years since the car was new. It says tell whether the model is growth or decay. All right, well, look at the b value, the 0.85. That is less than 1, so we have decay. It says identify the annual percent increase or decrease in the value of the car. Well, we have to go back to our cheat sheet because I forgot to tell you here for our real life model for decay, you subtract the rate. Okay, so make sure you add that to your cheat sheet. Decay is subtraction, and look at that. Growth was addition. Okay, sorry I forgot that, guys. So we know it's decay. Basically, we have 1 minus the rate equals 0.85, which means the rate is 0.15 or 15%. Because remember, to change from decimal to percent, you want to move the decimal 2 places. Okay, it says estimate when the value of the car will be $8,000. Keep in mind they said that y was in thousands of dollars. So you take your 25 times 0.85 to the t, and we're going to plug it in. So I'm going to put you on pause so I can get it up on my Desmos. You go ahead and get it in your calculator. Okay, hopefully you got that into your calculator. Here's what I have. I have the 25 times 0.85 to the x. That is the red function here. And then I have 8 plus 0x. Now in your calculator you can just put 8, but in my online grapher I have to put the x as 0 in order for it to give me this blue line. Now what they're asking is where do these cross? So if you were looking at this in your graphing calculator, you would be looking in a 10 by 10 window. So you should be able to see it. I'm going to zoom a little bit. Remember that the x-axis is years. So right here it says that it is 7.011 when the y value is 8. So that's about 7 years. So I'm coming back to my problem and I will say, I should have said the word about 7 years. Okay, let's try another one. It says in 2000 the world population was about 6.09 billion. During the next 13 years, the population increased by 1.18% each year. Write a growth model giving the population y in billions t years after the year 2000, and then estimate the population. Okay, so remember growth is y equals the initial amount times the quantity of 1 plus the rate to the time. That's our growth function. So what is the initial population? The initial population is at 6.09 billion. And now what is the rate? It's not 1.18%. That's not allowed. You have to put your rate as a decimal. So that's going to be 0.0118. And we're raising it to the t. Okay, so I ran out of space here, so I'm just going to bring it down here under B. That means it's the population of the world equals 6.09 times 1.0118 to the t. Now what I have to do is plug something in for the t. So this is one answer. And in for the t, I'm going to put not 2005, but the number of years since 2005. So go ahead and put me on pause and plug that in your calculator. Okay, so I have 6. Let's see, I can't type now. 6.09 times 1.0118 to the 5, because from the year 2000 to the year 2005 is 5 years. I got that the answer is 6.45789. So that's going to be billion. So we can round that somewhere. Let's just say it's 6.5 billion. Now it says estimate the year when the world population was 7 billion. Well, we already know it's going to be really close to 2005, but go ahead and put it in your graphing calculator. You're going to put this in your calculator, and you're going to put a 7 in your y sub 2 and see what it looks like. Okay, so grab your calculator, get it plugged in here. I have it over here. The intersection is right here. It says it's 11.871 on the y when x is, on the x when y is 7. So that's 7 billion people, 11.8 years after we started. 11.8 years after. Now that's not the answer yet. They want to actually know the year that it was 7 billion. So we're going to take the year 2000 and we're going to add 11.8 to it. And we're going to say that it was sometime in the year 2011. Okay, so this problem has 3 answers. I have a model, I have an answer for when it's the year 2005, and then I have a guess for when the population will be 7 billion. Okay, it says the amount Y in grams of the radioactive isotope chromium-51 remaining after T days is Y equals A, that initial amount, times 0.5 to the T over 28, where A is the initial amount in grams. What's the percent of chromium 51? What percent of the chromium 51 decays each day? Okay, so we've already talked about how it's decay. We're going to split it up because we know that Y is equal to the initial amount times the quantity 1 minus R to the T, but we don't have to the T. We have to the T over 28. So the very first thing we have to do is separate. This is going to be raised to the T, and that 0.5 is going to be raised to the 1 over 28. Now we learned that. We did that. That was back when we were talking about exponents in chapter 5. We learned that you'd basically just distribute in or multiply in the exponent, the product of powers, I think is what it was called. So now that they're separated, you can actually plug 0.05 to the 1 over 28 in your calculator. And when you do, you get Y equals the initial amount times 0.9755486 to the T. Now, the reason that's important is because we know in our decay model that it's 1 minus the R. So now in your calculator, do that. Do 1 minus 0.9755486, and you will get approximately 0.02445. Okay, so what we want to do is move the decimal twice. That's 2.45%. Okay, we have another concept then having to do with money. Basically what happens is you put your money into a bank account and they compound the interest on that money a certain number of times per year. It's called compounded n times. Quarterly is 4, monthly is 12, weekly would be 52. Just you can compound your money daily, that would be 365. It doesn't matter, but n is the number of compounds. The amount A is in the account after however t years passes by. Okay, so let's go ahead and try a real life example here. It says you're going to deposit $9,000 into an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. Okay, so we want the amount. There's a principal amount, 1 plus R over n to the nt. Is that what it was? Let's go back and make sure. Yep. Okay, so plug in everything you know. You know that the 9,000 is how much you deposit. That's your principal. This rate needs to be turned into a decimal. The word quarterly is a 4, and it goes here and here. I have squiggles all over this problem. And t is your time. So you have 9,000 times the quantity of 1 plus. Now what's the rate? 0.0146. Make sure you change it. It's all over the 4, and it's raised to the 4 times the 3. Okay, now you know me. I'm going to stick this whole thing in my calculator all at once, and this is how we're going to do it. First you do 9,000. Then you open parentheses and you say 1 plus. Then you open parentheses and you say 0.0146 divided by 4. And you close those parentheses and you close those parentheses and you hit the caret key. And then you open parentheses and you do 4 times 3. and then you press enter. Okay, so put me on pause and go ahead and do this. Alright, so I just put it in my calculator and I got that my balance is 9,402. $9,402.21. All right, I hope you're having a good day.